Hi, this is lab number 4. My name is Michael Ainsworth,
And I'm Xian Lee.
and we're now going to explain the circuits we currently have. So we have the inverting and the differential amplifier here. We're going to start with the inverting amplifier. It's not currently hooked up to the digilant, but we'll explain how the circuit works. We have the op amp here, and the input and the output for the voltage source, and then we have the resistors here connecting the negative and positive inputs in series, and this other resistor is connected to the digilant. So now we'll explain how the waveform looks for this. Here we can see how the inverted amplifier works. It takes the input, inverts it, and then amplifies in the opposite direction. This is what it would look like for a 10 kilohertz frequency. And now we'll show you how we calculate the slew rate. To do that, we take a singular increase, and we can take the difference in the x and the y direction and find the derivative for this increase, and that will tell us the slew rate.
And here we have the differential amplifier, and the differential amplifier works by getting rid of the common gain and basically keeping the difference between the inputs of the two inputs. And so what we have done here is we connected the two inputs together and to find the common mode gain. And how it's measured, so it's measured by basically getting the output and the input, and dividing the peak to peak of the output by the peak to peak of the input. And since this right here, if you can see the range, that the yellow, the input, is tenfold the output, that's why it looks pretty close. In reality, the blue line is almost straight, and so the output is almost 0, which makes sense since the differential amplifier gets rid of the common inputs, and because we connected the two inputs together, they're the same input and they should be common, and so the common mode gain should be 0.
Yep. And to measure that, we use cursors. As you can see, we can measure each of the top and bottom for all of these. And to confirm that this works, we can increase the frequency, which will look like something like this. And this can be done for both amplifiers. And at high frequencies, you'll see that even a square wave will turn into a sine wave. And this is because at that point, the entire wave is getting impacted by the amplifier. Thank you.